All right, A2 homework. Let's get it. Review of Algebra 1. So we're looking at relation versus function, domain, range, and slope, basically. All right, number 1. We're given an ordered pair. So this is usually a set, right? A set. And we're looking at the domain. So what are the x's? So the x's are going to be, you can write them in descending order, right? -3, -1, 3, and 5. I guess ascending order, rather. The range is going to be, change colors, all the y values. 2 or -2, -2, 3, and -1. So what y's are used? Well, -2, -1, and 3. Now you may say, okay, well, -2 was used twice. I agree with you. But the range and the domain, these are all of the values that you are going to use, not how many you use, right? Just because there's -2 twice, I'm not going to write -2 twice in the range, in the brackets for the range, right? These are simply the numbers that you're going to use, not how many times you're going to use them, right? That it has nothing to do with that. These are the ones being used. Okay, and then we look to see, is this a function? So whenever we're looking to see if it's a function, you always look at the domain, right? The domain is what drives this to be a function. Do the x's repeat? That's the question that we really look at. And here we see that the x's are all single, right? -3, -1, 3, and 5. The x's did not repeat. So yes, this is a function because the x's did not repeat. X's do not repeat. And then we can plot this. 5, -2, -3, -2, 3, 3, -1, -1. So, oh, can't see it. There it is. 4 points. Okay. I guess you could have used the vertical line test as well. That would have been a legit reason. All right, number 2. What if we plot them first? Again, let's set notation. So you don't necessarily need that. That's more for me. But to be proper. 4, -2. 4, -2. 3, 2. -4, -4. 3, 4. So 3, 4. Okay. In the domain, we have what's used? All the x's, right? All the x's. So we have -4. That's the smallest. 3, 4, and another 3. Okay. Here, right off the bat, like right now, there's 2 3s. The 3s are repeating, right? So right now, I know that this is not a function, right? Because x's repeat. But I'm going to continue and write in the range, right? The y values. The y values. So the y values are the smallest, what? -4, -2, 2, and 4. So this one is definitely not a function. And not only that, but if you look at the graph and you do the vertical line test right here, one input, two outputs. So fails, I guess, as a reason, we could put fails the vertical line test. Right, if you go off the graph. But just analyzing the domain, we saw that the x's repeat. Okay, use the table. So looking at the table, the domain is the top row, the x's, right? 0, 1, 2, 1, 0. So what numbers are used? 0, 1, and 2. And immediately I see that the x's repeat, right? 0 and 0, 1 and 1. Immediately, not a function, right? Again, this x's repeat. But to be complete, right, the range 5, 6, 7, 8, 9. Okay. To the back. All right, we got some graphs. What's going on here? Use the vertical line test to determine whether the relation is a function. So, vertical line test. We draw a vertical line, and if more than one point is on this line, then not a function, right? Not a function. So, for number 4, if we go right here down the center, that would fail. I mean, that does fail. It fails the vertical line test. It just depends on where you put the line, right? So look, maybe if you see it with the thinner line. So all these points right here. So this is not a function. Fails the vertical line test, right? However, it is continuous because there's no breaks in the line. And if I do this as an inequality, so remember, domain, inequality, the x's is what we're talking about. What is the smallest value? What's the smallest value that x could be? So the smallest value for x is -4. But there's a open circle at -4. It can't actually be -4, but that's like the stopping point. So we say strictly less than. We're talking about the x's. And the most right, the greatest x could be, again, is at 3. Open circle. So less than 3. I don't know if you can see that. Right, so -4 is the smallest value for x, not including -4, up to 3, but not including 3. All right, range is the same idea, but for the y's. Right, for the y's. So the smallest y value is -2. I'll do it in blue. So -2. Here, we definitely can say this is or equals 2. Right, because you have all these points right here that have a solid black line. We're dealing with y, and the greatest y value is 3. So less than or equal to 3. Is there more? No. All right, you might have to rewind that a couple times. Okay, for number 5, vertical line test. If I draw a vertical line, can I do what I want to show you? Yes, I can. So look, no matter where we move the vertical line, it only touches the graph once. So it's safe to say that, yes, this is a function. And it is continuous, right? It is continuous. Now, for the domain in interval notation, right? This is the one with parentheses and brackets. The domain is going to be the x's. The most left x point, like the smallest x point rather, which is to the left, is going to be -4 with the bracket because it's closed circle. And the greatest x value to the right is going to be 3. Again, closed circle with the bracket. The range, the y values. So the smallest, least x y value is going to be -4. Oh, I take that back. Not -4. That's the x. It's going to be 1, right? 1. 1 is the smallest y value. And it's a bracket. The largest, however, what's the most y value that would come out? And it looks like right here would be 5. So don't fall into the trap of looking at this guy right here, right? Don't look at that. Only because there's a y value that's greater than that, right? This is only at 4. This is at 4. But there's parts of the graph that are more than 4 in terms of y. So 1 to 5. 1 to 5. Let's keep it going. Number 6. So here, vertical line test. We draw a vertical line, and then we see, is there a place where it touches the graph twice or more than once? Come on, bro. It is. I can't move it right now, but it is. It's going to be right here. So anywhere in this area, we see that it touches the graph more than once. So this is not a function. No, not a function. It is continuous, however. And in interval notation, the domain, again, the most left in terms of x, looks like it's right here. So this is going to be 1, 2, 3, 4, 5. Looks like -5 bracket because it's a closed circle. And look at on the right side. We have this arrow. That arrow implies infinity, right? Positive infinity. That's where it's going. So positive infinity to the right. All right. In terms of y, the smallest y value looks to be like right here, which is -1, right? -1. We include it, right? Because it's a solid line. And the largest y value, if you go to the top, this is the largest point or the most upper point. It's going to be 3 with a bracket. So -1 to 3. Okay. To just simple graphing, right? Think back to Algebra 1. Just graphing. Slope-intercept form. The number in front of the x is the slope. The constant, the single number by itself, that is the y-intercept, right? And the y equals mx plus b form. So the number that's in front of the x here, the slope, is -1. The y-intercept is 5. So it crosses the y-axis at 5. And the slope is negative. So I go down 1 and over 1, right? Rise over run. All whole numbers are over 1. And me personally, I always go to the right no matter what. So if it's positive, I go up. If it's negative, I go down. No matter what, I go to the right. So down 1 to the right 1. Down 1 to the right 1. down 1 to the right, down 1 to the right, and down 1 and right. Connect the dots, and there's our line. Switch colors. So for number 8, we'll stick with red. All right, for number 8, the slope. So y equals 5x minus 3. The slope is 5, so positive 5 over 1. And the y-intercept is negative 3. So we cross the y-axis at negative 3. And then we go up 5 and to the right 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Kind of off the charts here, but for the most part, it's going to look like this. And the last one. See if I can put it on the screen. Come on. All right. So y is equal to negative 3x plus 2. The slope, the number in front of the x, negative 3. So already I'm thinking I'm going down 3 and to the right 1. Down 3 to the right 1. And the y-intercept is positive 2. So crosses the y-axis at positive 2. And the slope tells us I could go down 3 to the right 1. Down 3 to the right 1. And then we connect the dots. Right. After you make a couple dots, you can kind of see the pattern. And you just fill in appropriately. All right, man. This has been fun. Catch you guys in the next video. Hopefully this helps. Peace.